In this lecture, we'll properly set it up so that we can use our input and get our player ship moving left, right, up, and down. Now that we properly have our input set up, let's get our player ship moving back in our player movement class. Let's open that back up in VS Code. And there's a lot of different ways we can handle movement inside of Unity. In this case, we're not needing to move a physics rigid body or necessarily collide with other physics objects, so we can just translate the actual player movement class, in other words, the player ship attached to this class, directly. Before we do that, I've noticed I've made just a little bit of a formatting, you could call it an error, even though it's just a bit of a preference. I'm just going to slide this bracket down to the next line to follow similar formatting as other instructors. Inside of update, let's just do a little test moving our transform, or our local position specifically, to the right just to see what that looks like. The syntax we use to do that is transform of this specific game object dot local position. And we can move this to any sort of vector3 local position relative to our parent game object that we'd like. So in this case, we just need a new vector3. We can go ahead and do that all on one line for now, and we'll clean it up in a little bit. And this takes in 3 different positions. So we can start using 0, 0, and 0 with the F connotation just signifying that it's a float. And for now, let's just move it along the X axis first just to see what that looks like. So we want to take our transform local position that it's currently at, specifically just on the X value. And then we just want to add some sort of offset to it. Well, let's just call this X offset to start. And above that, we can declare that variable. So X offset. And let's just declare it as a float. Well, let's have a think about what that is. We know we're going to need some sort of speed. We can call that control speed. And let's just make that a serialized field up top so we can expose it in the inspector. So how do we do that? Serialized field, float, control speed. And you'll notice I'm not actually going to implicitly type out private. C# is smart enough to know that by default it's going to be private unless we explicitly call something public. So we'll just call this float control speed. And we can just set this to something like 10F to start. We can change that around in the inspector later on if we'd like. And how do we make something frame rate independent? We times our control speed by time.delta time to make sure that it works the same on everyone's computer. All right, I'm just going to go ahead and cancel out these little comments. We don't need our start method for now. We can go ahead and delete that. We've got that cleaned up. Let's head back into Unity and just see what that looks like in the engine. And hopefully if we set that up correctly, we can hit play and we should be able to see our plane just slowly gliding off to the right. Next step, let's open back up our player movement class and actually use this vector2 value from our input. So we know we're going to need an X and a Y value from this vector2. We can actually just cache this reference up top directly at the top of the class. Let's create a vector2 called movement. In our onMove function from our action map, we can actually just take this value as this vector2 and just set movement equal to this vector2 every single time it detects any sort of input. Now we can actually just pass this movement vector2 on the X and the Y value directly into our X offset and then soon to be our Y offset as well. It doesn't really matter if we put this here, here, or here at the very end because we're just timesing 3 different floats together. I think it makes a little bit more sense intuitively at the beginning. So I'm going to take my movement.x value, which we know is nothing more than just -1 or +1, times it by our control speed, and then times it by time.delta time. With that, I think we're set to go. Let's head back into Unity and see if we're correctly moving back and forth left and right. Blow up my game view just so we can see it, hit play, and perfect. We are set. We are correctly moving back and forth to the left and right. However, it's probably a bit too slow. So while I'm actually still playing, I'm going to open up our player ship. We should see the control speed exposed in our inspector. So let's try something like 30 and see how that feels. Yeah, close. Let's try something like 50. I think I want my ship to be a little bit more snappy and responsive, so I think that feels about right to me. Just remember that when you exit play mode, you'll have to save that to 50 once again in the inspector before you move on. And that'll introduce you to this lecture's challenge. Give our ship some up and down movement using our movement vector2, similar to how we've implemented our left and right movement. Pause the video, give that an honest effort, and I'll see you back here in a few moments and we'll go through my solution. Welcome back. Let's open back up our player movement class. And right here below X offset, I just need to create a Y offset. So I'll just copy and paste this entire line, change this to y offset, and then instead of using movement.x, we just want to use movement.y to get the y value of this movement vector 2. We can use the same control speed, time.delta time is set up, and then we just need to plug this in to our local position vector 3 value in update. So again, I'm just going to copy and paste this entire line here, replace our 0f where our y value would be, transform.localposition.y, and then not plus x offset, but plus the y offset. I think the last thing I'd like to do is just reformat this into its own separate method instead of hard coding the logic directly inside of update. So I'm actually just going to highlight all of this logic here in VS Code. Scrolling over to the left, we have this little light bulb. We can left click that, and at the very bottom, you'll see extract method. I can double click that new method, press Control D to highlight both at the same time, and then I can rename this to whatever I'd like. I'm going to name it something like process translation. We're translating the ship back and forth relative to its parent game object, so I think that makes sense. Instead of calling it something like movement, that's already what our class is. In the next lecture or two, we'll also be updating rotation, so I think calling it something like process translation makes a lot of sense. The only other thing I'd like to do is just slide all of this code as a private method below our public methods. So I'm going to highlight all of this code, and while holding Alt, just use my arrow keys and slide it on down. Clean up our formatting a bit, and I think we look good. Let's try that out back in Unity. Let's blow up our game view, hit it to play, drum roll please, left and right movement, and yes, up and down movement as well. I also kind of like the illusion from our camera staying in the middle, where it almost looks like our ship is pointing directly towards the center. I think that actually looks pretty snazzy, just naturally without having to do any sort of additional code, because we've properly parented and childed our game objects. And with that, we've got the basics of our movement set up. When you're ready to move forward, I'll see you on the next lecture.